and welcome to Unstress Health. My name is Dr. Ron Ehrlich. Well, today's subject is one of the most important body regulators that we have. It is nitric oxide. And my guest is Dr. Nathan Bryan. Now, Nathan is a pioneering scientist, a health innovator, and a biotech entrepreneur who is literally reshaping the conversation about longevity, human performance, and the truth behind modern medicine, a subject we've explored many, many times on this podcast. Now, with over 100 peer-reviewed publications and dozens of patents, Nathan's groundbreaking work in nitric oxide research has helped transform countless lives. And I think you will find today's podcast transformative. I know I did. A former professor of molecular medicine, he left academia to challenge misinformation in the health industry. Boy, is that ever a big subject, and bring real science-based solutions directly to the public. He is the author of The Secret of Nitric Oxide, bringing the science to life. And today, he's a sought-after speaker known for translating complex science into practical, actionable insights. Now, there are many aspects to this conversation today that I've found really interesting. I've been looking at nitric oxide for over 15 or 20 years because of its effect on nasal breathing, or the effect that nasal breathing has on it. I've also explored the whole fluoride issue and thought of it in many different terms, but today is a truly aha moment that puts an entirely new perspective on the use of fluoridation in the water supply and in mouth rinses and toothpaste. That's not the main subject. We cover a wide range of issues, from high blood pressure, athletic performance, erectile dysfunction, well-being, longevity, the list goes on. I hope you enjoy this conversation I had with Dr. Nathan Bryan. Welcome to the show, Nathan.
Thanks so much for having me. It's great to be with you.
Nathan, nitric oxide, what a subject. People often confuse it with nitrous oxide, and I'm looking forward to talking to you about it. But I wondered if you might just give us a little bit of your background first.
You know, I'm a small town Texas boy, grew up in rural Texas, just outside of Austin. I got a degree in biochemistry from the University of Texas at Austin. And then from there, I went to LSU School of Medicine. I got a PhD in molecular and cellular physiology. From there, I went to Boston University Medical Center, where I trained as a cardiology fellow in vascular biology. And then I was actually recruited by one of the guys who won the Nobel Prize for the discovery of nitric oxide, and got my first faculty position at the University of Texas Health Science Center in Houston at the Institute of Molecular Medicine. That's where I started my independent research career in nitric oxide.
Wow. Well, we could unpack, there's so much to unpack there, but we're going to talk about nitric oxide. So tell me, what exactly is it? Why is it so important? How do we know if we're deficient from it?
Well, nitric oxide is a signaling molecule. It's a naturally produced molecule. In fact, it's a gas. And the Nobel Prize was awarded in 1998 for the discovery of nitric oxide as a signaling molecule in the cardiovascular system. And the fact that the discovery that there was a gas that could permeate cell membranes and initiate signal transduction in other cells was a completely new kind of paradigm in cell signaling. And so that was the basis for the Nobel Prize. But nitric oxide it dilates the blood vessels. It was first recognized as a vasodilator. So it opens up our blood vessels and improves oxygen and nutrient delivery to every cell in the body. But it's much more than that. It's actually it's a signal that tells our own stem cells to mobilize and differentiate. It's a signal that tells our mitochondria, the cells, to make more mitochondria, and the mitochondria to make more energy with less oxygen. And it also signals an enzyme called telomerase that prevents our telomeres from shortening. So all of those three things, stem cells, mitochondrial function, and telomerase activity, really determine how long we live, how well we live, and how efficient our body works. So it's a foundational molecule for health and longevity.
I was really introduced to its importance, and my background is dentistry, actually. But it was when somebody said to me that 60% of your nitric oxide is produced in your paranasal sinuses only when you breathe through your nose. Wow.
That's right.
When somebody said that to me, that's such a huge statement, because there are so many mouth breathers for so many reasons, allergies, narrow jaws, posture, a whole range of things. But to hear that 60% of the body's nitric oxide is produced only when you breathe through your nose. And to hear about, as we're going to discover today, how important it is, that was a huge statement.
No, for sure. And certainly it explains the clinical consequences of mouth breathing and what happens in these people who fail to breathe through their nose. So all of that, kind of the clinical observations we take into account, and then we work backwards and figure out mechanism. But yeah, the loss of nitric oxide production explains really the rapid onset and progression of most, if not all, age-related chronic disease.
Wow. I mean, there is a statement in itself. How does nitric oxide, why is it so important?
Well, it regulates important things like blood pressure and blood pressure control. And, hypertension is the number one driver of the number one killer of men and women worldwide, which is cardiovascular disease. But if we just look at the role of nitric oxide in the cardiovascular system, in the inside of the blood vessels. So when we make adequate nitric oxide, it basically downregulates all the adhesion molecules, so white blood cells don't stick, platelets don't stick. You don't get lipid extravasation, you don't get plaque buildup. And so when you lose the ability to produce nitric oxide, you get upregulation of adhesion molecules, your blood vessels become like Velcro, things stick, platelets stick, and you get plaque deposition, and eventually you get obstructive disease, cardiovascular disease, and eventually that plaque becomes unstable, it ruptures, and we call that heart attack or stroke, depending upon where that thrombus ends up. But more than that, if you look at the hallmarks of chronic disease, whether it's Alzheimer's, whether it's heart disease, liver disease, kidney disease, pulmonary disease, there's always four common denominators. That organ is always associated with decreased blood flow. We call that hypoxia or ischemia. There's always inflammation, oxidative stress, and immune dysfunction. And so it's the loss of nitric oxide that really sets the stage for all of those. And so if we can, what we find both in the basic sciences and the clinical translation of that, if we give nitric oxide or we restore the body's production of nitric oxide, we dilate the blood vessels. So now we're getting adequate perfusion to that organ. We decrease inflammation. In fact, I've got a number of patents that are a method of reducing inflammation by giving nitric oxide. It inhibits oxidative stress because we're recoupling the electron transport chain of the mitochondria, and it corrects the immune dysfunction. So nitric oxide affects every single thing we know about every single age-related chronic disease. And so we've made it too complicated. We've made medicine too complicated. We got to get back to root cause, and it's the loss of nitric oxide, the functional loss of nitric oxide that precedes all the structural changes we see in the vasculature and the onset and progression of symptoms.
I mean, they're huge. Blood flow, inflammation, oxidative stress, immune function.
That defines all diseases.
That defines all diseases. And I was really surprised to hear that, because we got very involved in that in my professional career because of the propensity for people to mouth breathe versus nasal breathing. And we were just talking prior about the importance of nasal breathing. Before we came on, I said to you, I've always known or been told that 60% of the body's nitric oxide is produced in the nasal passages only when you breathe through your nose. So the implications of how we breathe, be it dysfunctionally through our mouth or functionally through our nose, are quite profound.
Now, look, I think it's even more serious than that, because not only are you bypassing this nitric oxide production in the nasal epithelium, but when you're breathing through your mouth, you're changing the entire ecology of the oral microbiome. Oh, yeah. And about 20 years ago, we and others discovered that the bacteria that live on the dorsal part of the tongue, part of their job is to produce bioactive nitric oxide that regulates systemic blood pressure. So when you bypass nasal breathing, you're disrupting the oral microbiome, causing oral dysbiosis, further decreasing nitric oxide production. It's this feed-forward mechanism that patients spiral out of control. They have complete dysbiosis, they're nitric oxide deficient, they have an increased risk of, 10-fold, 10, 20 times higher risk of heart attack and stroke and cardiovascular disease. And we can explain that mechanistically by nitric oxide.
And there's a little bit of a paradox, isn't it? Because people mouth breathe because they believe their nasal passages are blocked, and often that is the case. Yeah. But the paradox here is that nitric oxide is a bronchodilator. In fact, if you breathe through your nose for a short period of time, and I used to trial patients with a bit of tape on their mouth, and I'd say, let's just try this experiment where we put tape on your mouth and see what happens. And initially, there would be three groups of people. One, no problem at all. Two, those that were blocked, and then their nasal passages unblocked because of, I guess, the impact of nitric oxide. And the third group who were really blocked and they needed treatment. What is that? Have you noticed those kind of observations?
No, we have a nitric oxide analyzer, and we can actually detect nitric oxide in the gas phase. And we can detect nitric oxide coming out of the exhaled breath or out of the nasal passages when we do nasal breathing. But the key to that pathway is the enzyme in the epithelium must be functional. And here's what we're finding, that in most people that have a lot of the risk factors for cardiovascular disease that disrupt nitric oxide production, their enzyme isn't functional. So even though they're nasal breathing, the enzyme isn't able to make nitric oxide. So we have to first focus on fixing the enzyme, making it functional again, so that when you nasal breathe, you can actually produce nitric oxide. And we can see this as an age-related decline in nitric oxide production, not just in the lining of the blood vessels, but in the nasal epithelium. Because when we oxidize 𝗘𝗽𝗶𝗀𝗢𝗃, Nasal uncouples and we no longer make nitric oxide. So anything that leads to oxidative stress is going to decrease nitric oxide production. But it's all interconnected, because if we restore nitric oxide production or give nitric oxide, it prevents the oxidative stress, it recouples the NOS enzyme, and now our body's ability to make nitric oxide on its own is improved. So it fixes, nature has a way of fixing itself, and it's a remarkable system.
Yeah, look, the more I learn about it, the more exquisitely balanced and phenomenal it is. I mean, people often confuse nitric oxide with nitrous oxide, and let's just get that one out of the way straight away. They're not the same thing.
Well, no, they sound similar. They're both gases. One's a dental anesthetic, and nitrous oxide is N2O, the chemical formula. Nitric oxide is NO, one nitrogen, one oxygen. But yeah, one puts you to sleep and one provides you life.
Yeah. Wow, it doesn't get more fundamental than that. People may not have been aware of its importance. How do we produce nitric oxide? I mean, we talk about nasal breathing, but where do we get our nitric oxide from, and how can it go wrong?
Well, the first pathway to be discovered was through this enzyme, nitric oxide synthase. It's found in the lining of the blood vessels. It's found in neurons, and our immune cells express this enzyme. And so this enzyme converts L-arginine, which is a semi-essential amino acid that's made in every cell in the body, and we also get it from the breakdown of protein, both plant and animal proteins. And so L-arginine binds to the enzyme nitric oxide synthase, and through a very complicated 5-electron multi-step oxidation reaction, we make nitric oxide gas. And then we get L-citrulline as a byproduct. And then within that cell in which it's made, the citrulline is reconverted back to arginine. Arginine goes through nitric oxide. So we have a really exquisite intracellular, intraprotein shuttling of these metabolites. So that's number one. It's enzymatic from the conversion of arginine to nitric oxide.
And then arginine is one of those 20 amino acids.
That's right. It's a semi-essential amino acid. Yeah. But the interesting thing, we're never deficient in L-arginine, so we don't need to give L-arginine. In fact, many companies are selling so-called nitric oxide products and trying to give the body arginine, L-arginine. But we're never deficient in L-arginine, so it makes no sense to supplement. So we'll come back to that later. So that's the first pathway. And then another compensatory kind of redundant pathway is through diet. So when we eat green leafy vegetables, which are enriched in inorganic nitrate, we consume those 90 minutes after we consume them. They're concentrated in our salivary glands. So now each time we salivate, we're secreting nitrate in our saliva, and there's nitrate-reducing bacteria on the dorsal part of the tongue. And these bacteria convert nitrate into nitrite. And this is a very important step because humans do not have the capacity to do that. Humans do not have a nitrate reductase enzyme. So this pathway is 100% dependent upon certain oral bacteria. And now these bacteria provide nitrite in our saliva. We swallow our own saliva. Hopefully we're swallowing and not spitting. And then when that nitrite hits the acid environment of the stomach, it becomes protonated in the acid environment and we produce nitric oxide gas. So that multi-step pathway, and we control systemic blood pressure, controls inflammation. So you can begin to imagine if you're using an antiseptic mouthwash, if you're using fluoride, that kills all the good bacteria as well as the bad bacteria, you disrupt this nitric oxide production cycle. If you're using antacids, you're disrupting this nitric oxide production cycle. And if you don't eat a good diet that's depleted of any nitrate, then you're not fueling this nitric oxide pathway. So those are really the two simple systems that produce nitric oxide. And one can compensate for the other, but if you have endothelial dysfunction and you have a poor diet, or you use mouthwash or fluoride, or you're using antacids, then you become completely nitric oxide deficient, and that's when you run into trouble.
Wow, like this whole story around fluoride is such an emotive one, and it's a good example of how a profession is so narrow in its thinking that it views the tooth as everything, and whatever one can do to make the tooth supposedly harder is worth doing no matter what. I mean, the implications that might be downstream are, you're just an anti-fluoride person. You're not really, you know what I mean? It's just such an emotive issue. And I was once that person. Like I've been in practice for over 40 years, and for the first 15 years of my life, I just accepted the what I'd been taught. I just didn't. And then I started to explore it in lots of different ways, although you've introduced me to another way there. And I just kind of think, it's not an essential nutrient, fluoride, although interestingly, Nathan, if you look at a modern biochemistry textbook, somehow it has found its way in to being an essential nutrient in some biochemistry textbooks.
Well, all I do is look at the periodic table and look at that column that we call halogens, which are extremely electrophilic molecules. They steal molecules, they cause rust, and oxidation is a loss of an electron. But they're toxins, especially fluoride. It's one of the most electrophilic molecules out there. But what I look at is, when I ask the question, why are we doing this? And have to look back is, what started this? And as 100 years ago, this oral systemic link was first recognized, that there's translocation of pathogenic bacteria through bleeding gums. They become systemic. They induce systemic inflammation, cause plaque rupture, and heart attack. So the thought process was 100 years ago, well, we have to, let's throw an atomic bomb in the mouth and let's kill all the bacteria to protect the patient.
Yes.
Well, that was long before we ever recognized there was a microbiome, that there's bacteria that live in and on our body that are providing an essential metabolic function, a true symbiotic relationship. And I think no one out there, whether dentist or physician, would tell a patient to take an antibiotic every day for the rest of their life, because we know that disrupting the microbiome causes systemic disease. So I would have the same argument for dentists. Why would you give an antiseptic every day to destroy the oral microbiome and not expect there to be consequences? We and others published, probably 20 years ago, if you take normotensive patients and you give them mouthwash, their blood pressure goes up. What's the connection? Well, we do tongue scrapings, we culture the bacteria, and you're completely killing these nitric oxide, nitrate reducing bacteria. So now there's a clear mechanism between the treatment and the observed clinical effects, and it comes back to nitric oxide. So now the question is, once we recognize that, we go, okay, can we take hypertensive patients and target the microbiome and stop using antiseptics, get rid of fluoride, and then if we target the microbiome, improve the diversity, can we bring blood pressure down? And the answer is yes.
Yeah.
I mean, think about the public health benefits of that and the public policies of that, because hypertension is the number one driver, the number one killer of men and women worldwide. And instead of eradicating the bacteria, let's support the bacteria, support nitric oxide production. Blood pressure comes down. I mean, it's very simple. I mean, the science is there. We don't need more experiments. We don't need more data. We need the acceptance of the preponderance of data implemented into clinical practice, both in medicine and dental medicine.
Hi, Dr. Ron here, and I want to invite you to join our Unstress Health community. Now, like this podcast, it's independent of industry and focuses on taking a holistic approach to human health and to the health of the planet. The two are inseparable. There are so many resources available with membership, including regular live Q&As on specific topics with special guests, including many with our amazing Unstress Health Advisory panel. Now, we've done hundreds of podcasts, all worth listening to, with some amazing experts on a wide range of topics. Many are world leaders. But with membership, we have our Unstress Lab podcast series where we take the best of several guests and carefully curate specific topics for episodes which are jam-packed full of valuable insights. So join the Unstress Health community. If you're watching this on our YouTube channel, click on the link below or just visit unstresshealth.com to see what's on offer and join now. I look forward to connecting with you.
I remember doing a program years ago with a professor of immunology who had gone and supplemented a whole Chinese population. I think there was only about 10 million people involved, as is the way. And he supplemented them with, I know, it's just a drop in the ocean in China, but he supplemented with iodine. And apparently 2 billion people in the world have an iodine deficiency. And I asked him, does fluoride displace iodine from the thyroid gland? And the answer is yes. So if you had a choice of putting fluoride or iodine in the water, what would you do? And the answer is pretty simple, but that's kind of heresy in the dental world. If I was speaking to a dental group and I said I had misgivings about fluoride, they wouldn't hear another thing I said for the next half hour, if ever again, because it would be heresy. But coming back to nitric oxide, because this is such a powerful regulator of the body, and I know people may feel it may be a bit too esoteric. It's not. Tell us about its impact on sexual function. That could be something that gets people's attention, and for the really the athletic performance as well. Tell us about the impact of nitric oxide on those two activities.
Well, erectile dysfunction is a symptom of nitric oxide deficiency. And so how this works is when we're stimulated, so the sex organs of men and women are innervated with what we call non-adrenergic, non-cholinergic nerve endings. So when we're stimulated or we have chemistry with our partner, those nerve endings fire and it produces nitric oxide. And then that causes a little bit of vasodilation. Then the endothelial cells produce more nitric oxide, so we get more vasodilation. And then we get an increase in blood flow. We call that engorgement, and that's an erection. And the same thing happens in women. You know, for women to have a clitoral erection, they have to increase the dilation and increase blood flow. And for women to have an orgasm, they got to increase in pressure. The pressure comes from an increase in volume. The volume comes from an increase in vasodilation from nitric oxide. So if your blood vessels can't make nitric oxide, you don't get dilation. Men get ED. Women become anorgasmic because without vasodilation, there's no increase in pressure, and women can achieve orgasm. And in fact, the drugs, the PDE5 inhibitors, the drugs like Viagra, Cialis, and Levitra that have been on the market since 1998, work because they work downstream of nitric oxide. These drugs do not affect nitric oxide production. And the pharmacology of these drugs tells us everything we need to know about the regulation of sexual function, because these are called phosphodiesterase inhibitors. They inhibit an enzyme that degrades cyclic GMP. So the way normal smooth muscle relaxation works is nitric oxide is produced in the lining of the blood vessel. It's a gas, so it diffuses into the smooth muscle that surrounds the blood vessel. It activates an enzyme called guanylyl cyclase. That enzyme converts GTP into cyclic GMP. This gets complicated, but bear with me. And then cyclic GMP is the second messenger that releases calcium from the smooth muscle, which causes relaxation. And so the phosphodiesterase inhibitors prevent the breakdown of cyclic GMP. And that's why sometimes you're warned against 4-hour erections, because nitric oxide turns the switch on and the PDE5 inhibitors keep it on. But 27 years now on the market, and we know that only 50% of the men that are prescribed these drugs respond with better erections. So why do 50% of the people not respond? It's because they're not making enough nitric oxide to activate that second messenger system. So the mechanism of action of these drugs tells us from day one, erectile dysfunction is a symptom of nitric oxide deficiency. So again, now we have clinical data. If we give nitric oxide or restore the production of nitric oxide, those 50% that didn't respond to PDE5 inhibition therapy now responsive. And so you can lower the dose, or best case scenario, you can eliminate drug therapy, because once we give nitric oxide, all the other signaling cascade and signal transduction is in place, and we get vasodilation and we get normal erectile function. So it's very simple in terms of vascular biology on how this system works.
How do we supplement nitric oxide? Nitric oxide, yeah. How do we supplement that?
Well, I've developed technology that actually produces nitric oxide gas, and it's unlike any other dietary supplement on the market. Most other supplements are giving you precursors and substrates, and they cross their fingers and close their eyes and hope your body can convert it. But the reason people can't make nitric oxide is because they can't convert it. They can't utilize those precursors. So what we do is we make an orally disintegrating tablet. And I designed this. It's the only solid dose form of nitric oxide gas. And this was based on my years of research as a professor of molecular medicine. But you put this lozenge in your mouth, and I designed it to have a resident time of about 5 to 6 minutes. So as it's dissolving, it's releasing nitric oxide. And we can see dilation of your carotid within about 10 to 12 seconds. It goes systemic, it's transported, and we dilate blood vessels, we normalize blood pressure, we normalize the vasomotor response. And so now we restore the function of the enzyme. So when you're activated or stimulated, the enzyme is actually recoupled. We're producing nitric oxide. And because it sits in the mouth, it's restoring and improving the diversity of the oral microbiome. It's killing the bad bacteria. It's restoring the populations of the good bacteria. And when we do that, we're restoring the natural production of nitric oxide from both pathways that we discussed earlier.
Wow, that sounds quite remarkable. And that is in a tablet form or lozenge?
It's what we call an orally disintegrating tablet, an ODT. But yeah, it's a lozenge. Some people call it a lozenge, but we call it an orally disintegrating tablet.
Right. And what is the what is that? That is it's a supplement. It
is. Years ago, when I was in academia, we're designed to develop drug therapy. Really, my charge in the Institute of Molecular Medicine was to understand the mechanism of disease to the extent that you could develop rational therapy. So when I figured out a way to make a solid dose form of nitric oxide as drug therapy, when I went to the FDA, we hired a few lawyers to get a letter of opinion. And because I was screening natural product libraries and I was using natural products to produce nitric oxide, really recapitulating what the body would normally do, but in an isolated system. So we had clearance to bring this to market as a dietary supplement. Drugs on average take about 10 years and $800 million. So I started a company and we brought this to market as a dietary supplement. So it works great, but we're actually today taking that same technology and developing it as drug therapy because we see such a benefit. And I want to make sure that we go through the rigor of getting indications and drug approval so that not only, supplements are important because, people have worldwide access to it without a prescription. But drugs are also important because physicians need to feel confident that they can write a prescription for a drug that's not only safe, but effective in treating the disorder or the diagnosis. And that's what we're working on now, a drug for heart disease. We've got a drug for Alzheimer's, and we're making a topical drug for diabetic ulcers. But in the meantime, to fund those very expensive drug studies, I brought to market a number of consumer products, dietary supplements. I make a skincare line of products that are nitric oxide centric to restore blood flow to the skin. And then we make a fermented beet powder for, as you mentioned, for performance athletes and to improve exercise performance. But then, it's the same thing with exercise. We have to dilate the blood vessels to improve oxygen delivery. We have to improve the function of the mitochondria so we don't get lactic acid buildup. And then we've got to induce what's called mitochondrial biogenesis so that each cell has more mitochondria generating more energy more efficiently. And that's what nitric oxide does.
Wow, that's huge, Nathan. I mean, very interesting. What are some of the biggest myths about nitric oxide supplementation? I mean, I'd be really interested. What kind of forms do these nitric oxide supplements come in, and what are some of the myths associated with them?
Yeah. Well, the biggest myth is that beets are nitric oxide. Beets are not nitric oxide. In fact, they're so far away from nitric oxide that it's laughable. But no, but let me give you the history on that.
But Nathan, let me just stop because terminology here. I think in America, what you call beets, we call beetroot. Is that right?
That's right. It's the beetroot.
Beetroot.
It's the beetroot.
Okay.
Yeah.
Okay.
So there are a number of companies selling a beetroot powder, beetroot juice, beetroot gummies and chews. But let me give you the history on that. In 2012, in the London Olympic Games, it was revealed that many athletes were drinking beetroot juice, liters of beetroot juice to improve their performance. And rightfully so, because there was some really good clinical data coming out showing that a standardized beetroot juice with a standardized amount of nitrate, as we talked about, could be converted to nitrite. We swallow it, we produce nitric oxide, and it can improve exercise performance. But again, it's reaching that threshold of nitrate, and it's assuming everybody has the right oral bacterium, and it's assuming that the stomach is making sufficient stomach acid production. So a lot of assumptions there. So when this came out, a lot of companies hit the market with beetroot because it had become very popular. But these companies don't understand the science and the mechanism of action. And I've tested every beetroot product on the market, and 99% of them contain no nitrate, no nitrite. They're what we call dead beets. The only thing they do is turn your pee and your poop pink and cause a lot of anxiety in the people. But it's dead beets. And that's the problem, because people and companies are calling beet nitric oxide, and beets are not nitric oxide. It's the biggest myth perpetuated in the nitric oxide science, and these companies must stop doing it because it could kill the entire industry. And I say that because people email me all the time because they see these commercials that are run, and they go, Nathan, I bought this beet product on TV and I've been taking it for 30 days, 60 days, and my blood pressure hasn't improved. I don't feel better. My energy hasn't improved. And they go, so nitric oxide doesn't work for me. Nitric oxide must not be that important. And that's a dangerous interpretation, because nitric oxide is always important. The problem is that company failed you, that product failed you because that product didn't produce nitric oxide. And that's why this is so important, and the conversation is so important, because these companies need to be held accountable, and they have to stop doing this. And yet, I used to test all these products. I'd go to medical trade shows and I would bring my NO analyzer and I'd say, bring me your nitric oxide products, and I would reveal to the consumer that it doesn't work. And then these companies that were selling at these medical trade shows got mad at me, and they'd tell the organizers, don't let Nathan back into this building, and if he comes, he can't bring his analyzer. So now when I go to these trade shows and I give talks, I can't bring my analyzer in there because these companies are paying good money to be there, and they don't want people to know that their products don't work.
Yeah, yeah. So why let a good commercial opportunity get in the way of science?
No, that's right.
Or why let science get in the way of a good commercial opportunity? What are some simple changes people can make today to boost nitric oxide levels?
Yeah, no, it's a great question. The science of nitric oxide is really pretty complex, but the solution, I think, is really pretty simple. So I tell people you have to do two things. You have to stop doing the things that disrupt nitric oxide production, and then start doing the things that we know activate it and promote it. So we'll take those one by one. Number one, if you're using fluoride in your toothpaste, you must stop. You must get rid of fluoride and switch to a non-fluoridated toothpaste. Number two, if you're using mouthwash, anything antiseptic, you must stop. Number three is if you're on antacids, you must wean off of these antacids and allow for your stomach to make hydrochloric acid. And then eliminate any food that causes an increase in blood sugar. These continuous glucose monitors are everywhere. I encourage everybody to use them and figure out what spikes your blood sugar. And if you eat something that spikes your blood sugar, don't eat it again, because it's shutting down nitric oxide production. So those are the four really things that you should stop doing. And now, once you do that, you've released the brakes on the body's ability to make nitric oxide. Now we can activate it. Moderate physical exercise, 6 to 8 minutes of high intensity interval training, 20, 30 minutes of moderate physical exercise, intermittent fasting, an 18-hour fast every day. When you eat, throw in some more green leafy vegetables to get a source of nitrate. And then 20, 30 minutes of sunlight a day. Sunlight, certain wavelengths of light can release nitric oxide. And then, it's really that simple. Then when all else fails, we have product technology that does it for you.
Wow. There's so much to unpack in that, Nathan. With my dental background, as I think I said earlier, fluoride toothpaste is just, the holy grail to the established dental world, because they are so focused on the tooth, and they sometimes forget that there's a human body attached to it. Although I must say I have heard of fluoride's impact on thyroid function, as we alluded to, and also on neurotoxicity. But gee, I think this could be a real aha moment for mostly men, often men, who have set this policy to even connect it with erectile dysfunction. Now, that could throw a whole new perspective on it for a lot of the decision makers in the world. And when I go through how to activate it, that is all about good health, really, isn't it?
That's right. Everything we know that leads to longevity and disease prevention is what leads to an activation of nitric oxide production. And so going back to fluoride, because it's less of a controversy in the US now, because last year the National Toxicology Program published a study looking at the risk benefits of fluoride and really the risk and the toxicity. That's their job. And what they found was that fluoride in the drinking water or exposure to fluoride in kids can lower IQ by as much as 7 points.
Yeah.
7 points. I mean, and it provides no benefit. Today we know that there's other things that can remineralize the teeth and prevent caries and all that. Well, that's not toxic. That's not poisonous. That's not a neurotoxin. It's not an antiseptic. So we can do better. We have to do better. And we have to stop doing the things we did 100 years ago because we know better. The science tells us we can't keep doing what we've been doing when we know better.
Yeah, yeah. And the other thing that I wanted to add to that list of activate, I've just put it out there. We talked about nasal breathing earlier, and I think there is a whole issue there about why people breathe through their nose or don't. Nitric oxide production through nasal breathing is another powerful tool. Is that a fair statement?
It can be. Doesn't necessarily mean it is, because the enzyme has to be functional, right? So the enzyme must be coupled and functional to where when you're nasal breathing, it can lead to a production of nitric oxide. But if you have endothelial dysfunction, you have epithelial dysfunction. So we have to focus on recoupling that enzyme. So now when you do nasal breathing, it produces nitric oxide. You can deliver nitric oxide to the airways, dilate the bronchioles, dilate the pulmonary arteries, and lead to better oxygenation.
How do we know if we've got endothelial or epithelial dysfunction?
Well, really, the only way to know and tell is there's functional measurement devices, and we use what's called flow-mediated dilatation. And there's some devices out there that basically what happens is you occlude the blood flow into the brachial artery for 5 minutes. So you just get a blood pressure cuff, you pump it to suprasystolic levels, and occlude blood flow for 5 minutes. And then when you release that cuff, you can either look through an ultrasound of the brachial artery and look at the degree of vasodilation, or what we call reactive hyperemia, the ability of the blood vessels to dilate. And the degree in which you dilate is a measure of the endothelial function and how well those endothelial cells in the blood vessels are producing nitric oxide to dilate those blood vessels. And so, unfortunately, they're not used that often, but they're very powerful diagnostic devices. In fact, in the US, they're reimbursable. They get a CPT code. But, not a lot of people use them because then the question, physicians in the US don't want to measure what they can't treat, right? Yeah. And they only think that what they can measure is worth treating. So we're missing nitric oxide because they don't measure it. If they did measure it, they really don't have any drugs or anything in their armament to treat it. But I think, that's where we're moving. We want to provide good science, valid science, safe and efficacious products so physicians can give this to their patients, whether it's an OTC product, whether it's a consumer product or a prescription drug.
And we will, of course, have links to that oral disintegration therapy tablet.
Yeah.
Yeah, the lozenge. What's the brand name of that again? And is it available how does one get that?
Yeah, it's N101. It's N101.com. So it's the letter N, the number 1, the letter O, number 1.com. So it's a 1 nitrogen, 1 oxygen for nitric oxide. So N101. And it's available online. It's a dietary supplement. It registers as a dietary supplement here in the US, so it's available to anybody. You don't need a prescription for it. We ship internationally. Where we've had a distributor in New Zealand and Australia in the past. But we've got a lot of people in Australia and in New Zealand that order our product. They become dependent upon it. The shippings that sometimes can be a little bit pricey, but we ship a lot of products to Australia.
Mm-hmm. Listen, this has been fantastic, Nathan. I knew it was going to be because I've known that nitric oxide is an important body regulator, but this has really taken it to a whole new level. I just want to finish up with this one question. Taking a step back from your role as a scientist, as an innovator, we're all on a health journey in this modern world as individuals. What do you think the biggest challenge is for us as individuals on that journey in this modern world?
It's the exposure to toxins, and it's really the food that we eat isn't really replete in nutrients. And so when you look back historically, and this goes back to the days of Linus Pauling, he famously said that chronic disease is from nutrient deficiencies. And I think we can add one thing more to that. It's exposure to toxins. It's toxins on our food, in our environment, in the drinking water. The frequency of 5G is known to disrupt a lot of physics and enzymology and disrupt nitric oxide production. So we live in a toxic world, and eating food that's not providing the nutrients that humans are designed to achieve through diet. And so, we almost have to supplement. We have to be very conscious and judicious and diligent about, not giving ourselves exposure to many toxins that are out there. But it's hard work staying healthy these days.
Well, Nathan, I want to thank you for joining us today, sharing your knowledge and wisdom, and we will have links to that site. And thank you so much.
Thank you, Ron. It's great being with you.
Well, there it is. I mean, some really interesting and surprising bits of information there, particularly surrounding fluoride. I've come to that relatively late in my career. I mean, I've been in dentistry for 45 years. So for the first 20 or so years, I was a fluoride advocate. I was towing the party line, which actually surprised me, but there it was. And then I decided to explore it from a neurotoxicity point of view, from a thyroid function point of view, from an iodine deficiency point of view, and immune function, etc. And I think it's a good example of the way modern medicine approaches healthcare. Dentists focusing on a tooth think that fluoride is a good way of going, but of course the tooth is connected to a human body, often a small complication, but one that definitely needs to be factored into every health study. But this nitric oxide story goes way beyond that, and I thought the whole connection there with erectile dysfunction was interesting, but also in terms of blood pressure. I mean, that is perhaps the biggest story globally, that high blood pressure predisposes you to this. Also, the fact that many supplements are out there, but not many of them are actually able to deliver what they say they do. So we'll have links to Nathan's site, which is n101.com, NO being the chemical term for nitric oxide, very different from nitrous oxide that you may have been exposed to in the dental practice. I hope this finds you well until next time. This is Dr. Ron Ehrlich. Be well.
Feeling stressed, overwhelmed? It's time to unstress your life. Join the Unstress health community and transform stress into strength. Build mental fitness. From self-sabotage to self-mastery. And together, let's not just survive, but thrive. Expert-led courses, curated podcasts, like-minded community and support, and much more. Visit unstresshealth.com today. This podcast provides general information and discussion about medicine, health, and related subjects. The content is not intended and should not be construed as medical advice or as a substitute for care by a qualified medical practitioner. If you or any other person has a medical concern, he or she should consult with an appropriately qualified medical practitioner. Guests who speak in this podcast express their own opinions, experiences, and conclusions.